So in today's class, what we are going to discuss that we will start with the linear programming part, that we will start with the mathematical one. So like I have told you that every person has one objective, that to maximize or minimize something, right? So like we have started with the example that you are in the student's phase and your objective is to maximize your CGPA. So if I am writing over here that you want to maximize your CGPA, you have to maximize your CGPA when you will satisfy some condition that you should have attendance at least 75%. That means attendance can be more, but it should not be less than 75%. So you are saying that this is my 75%, right? And next, you can say that the number of hours allocated to write the exam, that is your 3 hours. So that means number of hours for writing exam is 3, right? You have 3 hours. And then what you can say, suppose you are coming from home and you are coming from somewhere and you got late for the exam, but after 1 hour you are not allowed to come in the examination hall. That means entry to the examination hall, that should be less than equal to 1 hour before the commencement of your exam, right? So this was some set of conditions in which you want, there can be more, right? So this is just a basic that how you can start. So when you want to maximize or minimize something, here this you call, this is your objective function. And the condition that you should have to satisfy to achieve the objective, जो आपको अपने ऑब्जेक्टिव को अचीव करने के लिए कंडीशन सेटिस्फाई करनी पड़ेंगी, दैट वी कॉल एज कंस्ट्रेंट्स. Is it clear? So this is just the basic criteria that how we can start with this course, that every person has objective function that he or she want to maximize or minimize something subject to some set of constraint जो उसके satisfy होने चाहिए, तभी आप उस function को maximize या minimize कर सकते हो. Is it clear? Right? Since this is the general term, and we are talking about the mathematical terms, so that means this CGPA or this objective function should be in some mathematical form. So how can I write like this? I can write like this, maximize or minimize whatever I want to. I am taking any variable, जिस function को मुझे maximize या minimize करना है, I have called this as f of x. Z is just the name of variable in which your values will get stored, right? Subject to conditions. The function, the condition can also be a mathematical term, g1x. So here you can see कि जो आपकी inequalities थी, either it has less than equal to, or it can have equal to, or it can have greater than equal to. That means for the constraint, either you can have less than inequality, or you can have greater than inequality, or you can have, equal to inequality, or you can have greater than inequality. And here is some right hand side that you have to satisfy, right? This is one constraint, one condition. This can be the other. The same way I can have m conditions. Right? Here I have used the variable x, means जो भी आपको मैक्सिमाइज या मिनिमाइज करना है उसी के विद रिस्पेक्ट टू कंडीशंस भी होनी चाहिए ना. इफ आई एम सेइंग that this student want to maximize or minimize his CGPA. So is it happening? It will happen कि आपकी मैं attendance आपकी ले लूं 75%? No. The person जो आपको maximize minimize मतलब जो आपका variable यहाँ पे है उसके with respect to ही आपकी condition satisfy होनी चाहिए. Is it clear? The person like Arnav wants to maximize his CGPA, right? So I cannot take the attendance of Khushi or Stuti, right? So that means I have to take the attendance for Arnav as well. So the variable which you are taking in your objective function, it should be same as in your constraint. The next, so this kind of problem, we say, this is my mathematical programming problem. Mathematical programming problem in which you have one objective function that is either to maximize or minimize subject to some constraint that it should satisfy. So this is your mathematical programming problem. Sometimes we can also write this as MPP, that is your mathematical programming problem. Now, the functions which we are talking about, right? The function in objective function or the function in your constraint. So these functions either can be linear or non-linear, right? So that means your mathematical programming problem can be of your two types. One is your linear programming problem and one can be your non-linear programming problem. The shortest name that we use for linear programming problem, that we say this is my LPP, and for this we say NLPP, that is your non-linear programming problem. Is it clear? So it comes in two types. So you say my mathematical programming problem is linear programming problem if the objective function, that is f of x, and all your constraint gix are linear functions. And non-linear, you will say if any of the constraint or objective function f of x is not linear, then we say that is your non-linear programming problem. If given at least your one constraint is non-linear, then you say that is my non-linear programming problem. चाहे आपके सारे constraints जो हों वो बाकी सारे linear हों और आपका even आपका objective function is non-linear, then you call that mathematical programming problem as non-linear programming problem. Is it clear?
हाँ, मान लीजिए मेरे पास कुछ कंस्ट्रेंट्स आ गए, इसकी वजह से काफी स्क्वेयर और जो नॉन लीनियर है इसके स्क्वायर टर्म, इसकी वजह से सर्कल विल नो व्हिच इज डिस्क्राइब्ड विद इन दैट स्क्वायर. तो उससे लीनियर बोलता है, नॉन लीनियर बोलूंगा क्योंकि मेरा उससे कोई बाउंड्री कंडीशन सेट नहीं हो रहा.
The constraint actually which you are taking, if one of that should be non-linear, then you call that programming problem is non-linear. That you can remove that constraint, but you have to inscribe that circle in the square. That is also a constraint. So you all have studied linear functions. Can you tell me what is linear function? Linear function, that is your straight line, right? Mod of x will give you straight line. Mod of x is your linear or not non-linear?
सेट पे डिपेंड कर, अगर मेरा ऑब्जर्वेशन
The function I am not consider. I am saying linear function means tell me it is linear or not linear. So the answer is
any function which can be represented along some axis is called a linear function.
along some
Axis.
which axis? You can take one axis, two axis.
रोटेशन करके या कुछ भी करके अगर मैं उसे किसी एक्सिस के along रिप्रेजेंट कर सकता हूँ तो वो लीनियर फंक्शन है.
Anything else? The mod of x में पावर क्या है? तो mod of x linear है? होना नहीं चाहिए. I am asking, is it linear or not linear? Raise your hand for linear. Raise your hand for not linear. Those who have answered yes or no. So you should, from the starting, we are studying linear. Even in your 10th standard, you have made graph 2x plus 3y, that you take the intersection point 5x plus 7y. You take that lines, you talking about linear function. You have done so many calculus, integral equation. I am asking linear function. Mod of x is linear. dy by dx. सबने पढ़ा है ना डिफरेंशियल इक्वेशन. dy by dx is equal to mod of y. क्यों बोलते हो वो नॉन लीनियर डिफरेंशियल इक्वेशन है, जबकि उसमें y की डिग्री भी 1 है, dy by dx की डिग्री भी 1 है. Why it is non linear then? Sin of x की डिग्री 1 है. Mod of the same is mod of x. You can take mod of x. It is still dy by dx is equal to. In the definition, I am not considered about domain. I am asking just a simple question that yes, that you have taken so long. जो अब आपने छोटे बच्चे को कराना किसी लीनियर, उसको पता ही नहीं है डिफरेंशिएशन. He does not know about the rotation. He does not know about the transformation. How you will tell that it is linear? Mod of x has degree 1. Sin x में भी आप कंफ्यूज हो जाते हो, लीनियर लेना है कि नहीं लेना. चलो नॉन लीनियर है. x इंटू वाई, एक्स की डिग्री 1 है, y की डिग्री 1 है. क्यों नॉन लीनियर है वो? The simple definition. That what I am saying. You are telling a 7th class student, suppose I am asking the linear function. He does not know what is actually slope is. Slope same आ जाती है. You take a graph y is equal to x square and minus x square. The slope at some point it will be same. So that is linear function. Slope same आ गई ना. x square equal to y लो, y minus x square लो, तो एक पॉइंट पे दोनों की स्लोप will be parallel to your x axis. क्या वो आपके लीनियर फंक्शन है? फिर the slope you are the simple definition, even if I'll write you will understand. If you have any variables, I am talking about x1, x2, xn variables. It is a linear if I can only write this in the linear this sense. a1, a2, a2, x2 and an, xn. This is actually your linear function is. Linear function is when we are talking about mathematics. That what actually when you talk about mod of x, you cannot write mod of x in this sense. That's why it is your not linear function. Okay? You write your 2x1 plus 5x2. So you can write it as a1x1 plus a2x2, in which your a1's value is 2 and a2's values is 5. That's why it is your linear function. Okay? Either in any sense. If I am writing 2x1 plus mod of x2, I cannot write like this, that this is a1 x1. How I can write like this, that it should be a2 x2. It cannot be written in this sense. That's why it is not linear, right? So whatever thing is given to you, if you can write it in this sense, then it is linear. Otherwise, it is not linear. The concept, slopes, differentiable, rotation, transformation, that comes bit later. This is just the definition that it should be linear combination. Linearly, it should be written like this, that a1 x1 plus a2 x2 an xn. So even like when you notice some definition where you have confusion, जब आपसे पूछा जाता है ये नॉन लीनियर डिफरेंशियल इक्वेशन है या लीनियर है, लीनियर या नॉन लीनियर की भी अगर आप डेफिनेशन में जाओ ना, वो यही लिखते हैं that it should be written as a naught dny upon dxn plus a1 dn minus 1y dxn minus 1. वहां पे जब आपका मॉड ऑफ y या ले सकते हो, वो आप उसके लीनियर उसमें कॉम्बिनेशन में लिख ही नहीं सकते. That's why it becomes your non-linear differential equation, or sometimes whatever you can write. So this thing you cannot write like this, a1 x1 plus a2 x2. That's why it is your non-linear function. Is it clear now? Right? Next thing, since we are talking about linear programming problem, right? And I am saying that if the objective function and as well as my constraints are linear function, that means if I am considering x1, x2, xn variables, right? So what I can write maximize or minimize z, because I can write linearly. So I can write like this, c1 x1 plus c2 x2 plus cn xn. This will be my objective function. Whatever value c will take, I can always write that function in this sense. अगर वो मेरा linear प्रोग्रामिंग प्रॉब्लम के लिए मैं बात कर रही हूँ, तब आपका ऑब्जेक्टिव फंक्शन हमेशा इसी सेंस में होगा. ओनली योर कॉन्स्टेंट्स विल चेंज और आपके नंबर ऑफ वेरिएबल्स चेंज हो जाएंगे कि आप कितने नंबर ऑफ वेरिएबल्स ले रहे हो. सब्जेक्ट टू यू विल हैव सम कंडीशन ऑन दैट, कि अगर आपने पहला कंस्ट्रेंट ले लिया a11 x1, if I am taking n variables, so inequality can be less, equal, or can be greater. So you will have right hand side. So the second constraint you can write a21 x1 the same if you have m constraints, so you can write am1 x1, am2 x2, so this is nothing but this is your linear programming problem. So whatever problem you will have, you will always have in this sense that only the constants value will change. That is c1 x1 plus c2 x2 plus cn xn, and these are your constraints. When you are considering some problem, like you are considering the variables, right? So should there be any restriction on the variables as well? If I am saying that you have to plant two type of trees, type A or B, तो x1 आपने ले लिया टाइप A के ट्रीज, x2 you have taken type 2 trees, and whenever you have will solve the problem, so ऐसा भी तो हो सकता है कि आपके x1 और x2 नेगेटिव आ जाए. When you solve the problem, unless and until you are not telling, whenever you solve this problem, ऐसा भी तो हो सकता है वो वाली प्रॉब्लम मेरे नेगेटिव आंसर आ जाए. तो क्या नंबर ऑफ ट्रीज मेरे नेगेटिव हो सकते हैं? नहीं हो सकते, राइट? So sometimes we take the condition on the variables that we take that is greater than equal to 0. So these restrictions we call as non-negative restriction. So these are non-negative restrictions and these are my set of constraints. And this is nothing but this is my objective function. So every LPP will have one objective function, some set of constraints, and your non-negative restrictions. Because whenever we are solving the linear programming problem, we are considering the range that it should be in the first quadrant, that all your variables should be greater than equal to 0. So you have written like this. So if I am writing is this given problem LPP?
वो greater than equal to क्या है?
5.
नहीं minus 7x.
x1 plus 4x2 greater than equal to 8.
LPP.
So is this given problem LPP?
Yes.
Right? Because you can write constraint in the linear form कि ये वो c1 x1 plus c2 x2, and here this is a1 x2 plus a2 x2. This is something b1 x1 plus b2 x2, and here you have the constant. So this is nothing but this is an example of LPP. Is this LPP? Why? Because the second constraint you cannot write, sorry, the first constraint you cannot write as a11 x1 plus a12 x2. So because of this thing only, your linear programming problem does not remain linear programming problem. It has become your non-linear programming problem. Even if it remains like this, still it is your NLPP, because this thing you cannot write as C3x1 or C3x2. Is it clear? So it will remain your NLPP. So since you have done this LPP and this is nothing but a general form of linear programming problem, that is general form of LPP. Is it clear? Is it clear to all?
Yes.
Next, since you can write like the general form, can I write like this, that either it is maximize or minimize? The inequality can be less, greater than, or equal to. So here you will have so you have written C1, X1, C2, X2. So if you will multiply these two matrices, this will become C1, X1 plus C2, X2 plus Cn, Xn. And the first constraint will become A11, X1 plus A12, X2 up to so on plus A1, Xn. The sign can be less, equal, or greater. Then you have B1. Then you have second constraint. Then you can write, or you can here write as so since this we are writing in the matrix form, so what I can assume, that this is my C matrix, and this I can assume this is my X matrix, and I can take the set of constraint as my A matrix. That will be your M cross N order. This is X and this is my right hand side. So you can also write your LPP in the matrix form. So what is your matrix form of LPP? That is either you have a function maximize, minimize. You have Cx subject to Ax. The inequality can be less, equal, greater. And here you have B vector and you are taking X as greater than equal to 0. So this is nothing but this is the matrix form of your linear programming problem. Up to here, how we can write the LPP? Is it clear? Right? So the general notation, I have already told you when we have n variables, then we have come to the matrix form. And I have already told you that mathematical programming problem can be of your two types. Because the techniques which are developed, only we have less than, equal to, or equal to. We can convert that inequality, right? So whenever we will solve some method, we can convert the inequalities. If it has equal, then we can convert that inequality in less than, equal to, or greater than even equality. Up to here, any doubt? No. So the first and the foremost part, like we have given any LPP, but whenever decision maker comes to you, right, he does not give you mathematical model. वो क्या बताएगा? He will tell you in wordings that I want this requirement, this is my requirement, I have this budget, I want to have this in this budget, and I can invest only in this, I have only the capacity of one thing is this. So he or she, that the decision maker will tell you only in the wording. So the next task which comes in linear programming problem that is the formulation of the model, right? So formulation of model, that means you will convert the decision making problem into the mathematical form. So what it should have, the first and foremost thing, सबसे पहले क्या डिसाइड करोगे? Yes, set what variables you are going to take. So the first and foremost step while formulating a problem, that is your decision variables, that what you have to do with that decision variable. Second or third can be interchanged, but the first step will remain same. Because firstly, either you can make set of constraints or you can make your objective function first. The last is the restriction on your variables. So these are the 4 steps, right, that we need when we formulate any problem. So one is to decide the decision variable. Next is constraints, objective function, and the no-negative restrictions or restriction on the variable. So we will start with the problem for formulating a model. So the first example, we will start with the basics example, then we can increase the difficulty level. So the first problem is so the problem is given to you that a farmer has to plant 2 kind of trees, say A and B, on a land with 4,400 square meter area, right? These are some lines and these we have to make. The last, if you read, that you have to describe the plantation project of the farmer in terms of LPP so that the return is maximum. So that means from here you have decided that whatever will be your objective function, that will be your maximize of something, right? So everything over here that it is given to you, that is with respect to the tree A and B, right? So you have to plant 2 kind of trees A and B and you have to do the plantation project management. So what will be your decision variable over here? So I can take, let x1 and x2 be the number of trees of type A and B respectively, right? That actually what has given, that you have to do the project plantation and you have to plant 2 type of trees. The trees has some land requirement, water requirement, some availability of something. That means then you have to manage that how much trees of type A you should produce and how much trees for type B you should plant so that the return should come maximum. So since you have decided your object variables that x1 and x2, they are dealing with the number of trees of type A and type B. So that is given that the return is maximum. So my objective function will be maximize Z. Now we have to check that what is given. So where the return is return. So from here, you can notice over here, the return from one B tree it is saying that it is $50. That means return from one tree of type B is your $50. Then the return, कितने trees लिए आपने type 2 के? X2 of type B. What will be the return? $50x2, right? The next line it is written, while from one A tree is 1.5 times that of the return of from B. That means return from one tree of type A is 1.5 type of B. That means 3/2 of 50. That is nothing but your 75. That means return from X1 trees will be 75x1. So you have to plant both type of trees. So what will be your objective function? That this is 75x1 plus 50x2. Is it clear? Yes or no? So this is your choice. Either you can make objective function first or you can make constraint first, right? Now we come to the part of constraint. It has given that A and B, you have to plant on a land 45 meters square, right? A tree requires at least 25 meters square and B tree requires 40 meters square. Now that means one tree of type A requires land that is your 25 meters square. So that means X1 tree will require how much land? 25x1. And one tree of B, type B requires land that is your 40 meters square. And X2 tree will require 40x2. That means the constraint here will be 25x1 plus 40x2. And the availability of land is your 4400 meters square. Units अगर आप लिखोगे भी then both will have same units on both the sides that you can cancel. What will be the inequality sign over here? Less than equal to, because the available land is your only 4400. After that, you cannot go beyond that. So the next, the same. Water requirement for type A is 30 units. So for X1, it will be 30x1. For type B, it is your 15x2. And the availability of water is your 3300. Only this is the capacity which is available. So that means the inequality should be less than. The next it is given. It is estimated that the ratio of the number of trees type B to the number of type A should not be less than 6/19. That means it should be greater than 6/19 and not be more than 17/8. That means it should be greater than, less than equal to 17/8. So all the lines which is written over here you have solved. The next comes that you have to give restriction on your variables, right? Because you are planting the trees cannot be negative. So the first and foremost thing that your X1 and X2 should be greater than equal to 0. When you can solve this problem, the decimal can also become X1 और X2 आंसर डेसिमल में भी तो आ सकते हैं, बट क्या नंबर ऑफ ट्रीज डेसिमल हो सकते हैं? So that means here it is also following that X1 and X2 are also your integers. Is it clear? Okay, thank you.